At this point, you've looked at the video on how to estimate groundwater recharge from hydrographs giving you a measure of stream base flow. Let's look at some specific examples and see how this works. You have a link on the web page to the King County Water Resources site, and here is the graphical user interface provided by King County, and I've zoomed in on the region around Issaquah. On the right side you see the parameter being displayed is locations of stream flow, and you'll see that there are a couple, let's see if I move my pointer in here, a couple stations gauging Bear Creek right around downtown Issaquah. Now if you toggle to the precipitation, or let's see, and you click on that on one of the stations, and it shows you the location of the gauging station, and by clicking on one of the other tags there you could download data which would include daily, monthly, annual summaries of discharge for the creek. By toggling on the precipitation button, you can find out where King County is measuring precipitation. And in this case, I have a precipitation gauge on Bear Creek that is upstream from the gauging station. So at this point, clicking on the gauge metadata or downloading data, one can get all the precipitation information in this watershed. So I've downloaded the Bear Creek discharge data for a water year. So on this plot we have discharge as the vertical axis and day of the water year in the horizontal axis. And remember, October 1 is taken as the first day of the water year. So the discharge, as you can see, consists of a number of spikes, which are probably associated with large precipitation events, and periods between the spikes. Now this is a linear scale, and you can see it seems to range from near zero values to values up over 400 cubic feet per second. It's useful to plot this on a semi-log plot. Here we have the semi-log plot, log discharge on the vertical scale, so 1 would represent 10 cubic feet per second, 0 would represent 1 cubic feet per second, 2 is 100 cubic feet per second, and again as a function of water year. And on this plot the spikes are a bit compressed, and you can see the background base flow between the spikes. So remember, we have a stream hydrograph consisting of direct precipitation into the creek, interflow, which is the shallow infiltration that drains quickly into the creeks, and finally base flow, which is the infiltrated to the water table water that then discharges during the period between precipitation events. So how do these features line up with precipitation? I can plot all the precipitation data on the scale where now this is in inches, and instead of a log it's linear, and so 1 would be 1 inch of precipitation, and 2 is 2 inches of precipitation. So you can see that during storm events the precipitation values are up over 1.5 inches, and the discharge reaches its peak. So you have most of the precipitation occurring during the winter months, and then less precipitation during the summer months. So there is some, not a clear-cut example of base flow recession, but there's examples of base flow recession to be seen on this graph. So how are we going to get that? Well, let's just look at characteristics, and remember, a base flow recession ought to be characterized by a portion of a semi-log plot that is linear. So I'm going to identify slopes. You see the line that came in there that is in a linear portion of the data that is in a period in which there were no precipitation events. Here is exactly the same slope of a linear trend, but applied in a different region where there is a period of no rainfall. And looking across this graph, there are other periods between precipitation events that show the same linear recession behavior. So I'll bring in a few more. Now there is a steeper linear portion of many of these graphs, and I've drawn that in. And I suspect that that represents the interflow, the water that's penetrated into the shallow weathered layer of the watershed and is draining more rapidly into the creek, but not as rapidly as the overland flow. And finally, you see the peaks, which decrease very rapidly, which are probably the overland flow. Now, what is the base flow recession for this creek? Well, I've drawn a line here which is parallel to all the line segments which I believe represent base flow recession. That line shows a half log unit decrease over a period of 50 days. So that implies 100 days for a full log unit of decay. So 100 days works out to be about 8.6 million seconds. So now, what is the base flow for the creek? Well, here you have it. The portion that is not interflow and not direct precipitation or overland flow. And so the blue line there represents a curve encompassing that part of the stream flow that is base flow. And over the course of the year, it would be the area under that curve that would represent the discharge from the aquifer. In this plot, I've taken King County data from Judd Creek, and in fact this is the record that you'll use in your homework, and this is Vashon Island, Judd Creek, the largest watershed on Vashon Island, and this represents a number of water years. Count the peaks there, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 water years worth of data. Now you can see that there are the buildup of base flow during, and also notice this is a log plot. We're going from 1 to 10 to 100 to 1,000. As you can see, Judd Creek flows in the range of a few cubic feet per second up to almost 100 cubic feet per second during precipitation events. Now if I draw a line like the black one shown, and that line has a drop of 1 log unit over a period, and I'm going to count it on the graph, 1, 2, 3, 4, 5, 6, 7, 8 months. That slope you can find in every water year, and here I bring that same slope across, and you can see that recessional slope showing up, even though there are values that jump up much higher than that during the dry months, because obviously in the Northwest we do have precipitation events even in the summer. But I take that slope as representing the characteristic recessional time constant for Judd Creek watershed. And on each water year, one can then pick out the maximum value of stream flow, the Q naught, and can count the number of months over which the base flow recession occurred, and thus one could estimate year by year the total recharge of the aquifer, and one could then compare that with the precipitation and the infiltration for the watershed, and that will be a major component of your homework set. So with that, we are at the end of my lectures on the hydrologic cycle. I have one more video discussing water resources in southern Nevada, and after you view that, you will have reached the end of the lectures for Module 1.